In this video, we will demonstrate how the Interactive Parallelization Tool, or IPT for short, can be used to parallelize a program using MPI. MPI stands for Message Passing Interface and provides a framework that allows processes running in parallel to communicate with one another. The code on the screen is a snippet from a function search that we wish to parallelize. In this section of code, the function search takes the inputs a, b, and c. Search works by finding the x value for which f of j equals c. A and b are the upper and lower limits for which the function will search for j. The for loop that evaluates f of j from a to b is a good candidate for parallelization because each evaluation of f is independent of one another. We can invoke IPT from a command line and pass the source code in as an argument by typing IPT and then the path to the file. IPT first prompts the user to select a parallel programming model. We will be using MPI for our parallelization, so we will select option 1. Next, we will select what function the region of parallelization is in. Since our region of parallelization is in search, we will select option 2. There are many parallelization patterns we could choose from, but we will select option 1, which is for loop parallelization, because this best fits our needs. Next, IPT will show users possible for loops for parallelization. This is our targeted for loop, so we will tell IPT yes. We are not doing any data storage in the loop, so we can select option 7. We are almost done with our parallelization. We do not need to do this pattern again. For this example, we will say we're not printing anything since this will not change the final results. We are not reading or writing anything. We do not need to do any timing. Now that we are done, IPT will generate a file called rows search serial mpi.c. On the screen, we are showing the results from the serial version. You can see that it took the program about 100 seconds to run in serial. The return value for j is also shown here. When we run the parallel version, this value should stay the same. Now let's run and compile the program that IPT made. To compile the program using the Intel compiler, we will use the command MPI cc with the file rows search serial mpi.c. To run the executable, we will be using the command ibrun a.out. We are running the program on 2 nodes with 8 cores each. As you can see here, the time it took for the processes to find the solution was about 4 seconds. All other processes took about 16 seconds to evaluate in their regions and realize the solution did not exist. This increased program speed by quite a lot, as you can see, and the same value is returned for j. If we had wanted to, we could have let only the master process print to make the results a little cleaner to follow. In this case, we would just tell IPT yes to printing and give the lines accordingly. Thank you so much for watching. Please visit our website and user guides for more information and examples.